Good afternoon all. For today's technical session, I Snehal Dethe welcomes you all on behalf of AISSMS Polytechnic. For today's session, we are having a well-known personality for this FDP as an expert,
Good
being
afternoon all.
Commander Ajit Sapre sir. For today's in previous session, sir has explained deeply the information about drone technology. Now I request sir to start this session. Hello sir, it's over to you.
Thank you very much, Dethe ma'am. Good afternoon, everybody. I will just start sharing my presentation. We'll show a lot of videos, and I expect people to ask questions. More the questions, better will be the job. So I will request people to be free and ask questions either in chat box or later, so that your fundamentals can be cleared. I have deliberately tried to keep maximum things in terms of showing you actual projects and showing you video which are showing you, giving you a glimpse of latest technology and a lot of things which you can do. There are a lot of, like I told you last time, there are a lot of issues which are there with the drones, but people are finding different solutions to resolve those issues and coming up with different technologies. So let me start some with the what we have covered in the last. Let's share the presentation. Okay, so just to recap what we did last time, what are the drones, UAVs and RPVs? All are nothing but the same. All are unmanned. They are remote controlled. Either they can be, or mostly are remote controlled, or they are autonomous. They can go on their own, no interference or no control is required. The only difference between drones, UAVs and RPVs, UAVs are unmanned aerial vehicles. Any vehicles which fly in the air are UAVs. On the ground or below the water can be called as drones or RPVs. Most important thing which I am going to emphasize today is the payload. What payload you carry, the drone can be the same. Same drone can carry 7-8 different types of payloads separately or together and can carry different jobs. A lot of safety features, everyday new features have been added. They can be fuel or electric, they can be fixed wing, where wings are fixed, rotary wing, where the wings rotate, or hybrid, that is combination of the rotary wing and the hybrid, which I explained. The most important thing, advantages, I will show you some videos so that it will be very clear. That is comparison with fixed wing and rotary wing. Mostly you will see people using rotary wing aeroplanes or rotary wing UAVs for survey. All survey of India and other big companies where they have to cover large area, they will be using fixed wing. Fixed wings are much bigger, but they are efficient. They have got much better endurance. They cover larger area. They are most economical to operate. They are better against wind. They have better wind resistance. Their weight is less compared to the rotary wing. So in case of any failure, if they crash, the damage on the ground is much lesser. And always they can glide in case of engine failure with the help of wings, like the birds come down. You can make that glider glide and go to a safe place, which is not the case in the rotary wing. The greatest advantage of rotary wing, takeoff can be from any place, landing can be at any place. They can be operated at very low altitudes. I will show you a few interesting videos. They can capture much detailed information about the target or the site. They can easily carry out oblique photography because they can fly at a steady position. They can go up and down. They can go left and right. They can move forward, backwards. The camera angle can be tilted, which is not the case with the fixed wing. They are much cheaper and easier to fly. And certainly used for single object survey. Last time I covered advantage of aerial survey by drones. They are much faster. Like today only I had gone for a survey. The survey was to be done for 220 acres. I finished that survey and came back. Now I will process and give the outputs tomorrow. It can be very difficult terrain, much easier, faster and accurate in hilly and forested areas. I will show you a practical demonstration. It produces much accurate and exhaustive data. Many outputs for various applications. I will show you the 3D data in AutoCAD. And obviously, with no human error involved there. Let's see some videos now. Then we will start. Okay.
From mining to construction, topographical surveying is essential for getting the job right. The rise of drone technology is changing the way surveying is done, making it accessible to a wide range of industries. Drones offer enormous opportunities for surveyors and GIS professionals. With the help of drones, it is possible to carry out surveys and process and deliver surveying data in a timely, accurate, and safe way. Using drones for surveying and mapping has many advantages. Time saving. Traditional surveys can take days, if not weeks. With the power of drones, a survey can be completed in hours, and the collected data and imagery can be processed on the same day. This means that you spend less time in gathering data and taking the right decisions. Cost effective. The acquisition and operating cost of a drone survey is much lower than that of surveys through satellites and manned aircraft. The technical requirements for the site and personnel are also low, and the daily maintenance is simple. These factors eventually reduce the cost of data acquisition. Accessibility. With the help of drones, you can easily survey those areas that are otherwise difficult or even impossible to access. For cliffs, rugged terrain, and other areas where conventional surveying is challenging and time-consuming, drones offer a great advantage. Accuracy. Some of the most important parameters of surveying are spatial resolution and low-altitude multi-angle shooting. The spatial resolution can reach decimeters or even centimeters and can be used to construct accurate digital models and 3D landscape maps. Safety. Land surveying can be a risky job. Drones eliminate the need for surveyors to explore unknown terrain and can be helpful in avoiding high-risk places such as railway lines and rocky terrains.
I hope you could see the video.
Yes, sir. It was visible.
Okay. I will just shift to.
So over the past 12
I will just shift to the presentation.
Yes.
Okay. Can you see the presentation now, ma'am?
No, sir. Presentation is not visible.
Okay. I will just exit the presentation. Give me 30 seconds. Huh? It has.
Yes, sir.
Huh. Okay. There seems to be. Okay. 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 Now, can you see my presentation, ma'am?
Yes, sir. It is
Yes, sir.
visible now.
Okay. Wait. It
Just
is. It is having. Okay. Now can.
yes, sir.
Okay. Let's revise now. RGB camera. You saw what was the output of the red, green, blue, the normal camera. Thermal camera output you have seen in terms of the survey carried out of the solar panels. Multispectral camera, I will just show you. LiDAR and hybrid. Why this requirement of multispectral camera, LiDAR and hybrid? I will just show you the videos so that you will be very, very clear. This is the drone with a multispectral camera mainly used for agriculture and forest department. Different uh, frequencies or wavelengths are picked up by this camera, and it gives you a totally different picture, especially about the green light reflected by the plants. So let's see the video.
As the world population continues to grow, we need innovative ways to feed more people sustainably. That means leveraging intelligence in the agriculture industry to make operations smarter and more efficient. Meet the new tool that makes your workflow intelligent, the DJI P4 Multispectral. A high-precision multispectral drone solution designed to get you agricultural insights for targeted action. P4 Multispectral retains the same powerful performance as DJI's other drones, integrating a
Now you can see here that different cameras are capturing different wavelength, and every camera will give you a different picture of the same area, and you can get a lot of data and analyze that data to get maximum yield or to see any disease which has infected the crops, or any crop damage for excessive watering, or some places where there is less water. All things are can be detected by using this type of camera. So it has got 5 other frequency of wavelength cameras and one normal camera, so that you can always compare the image with a normal image what you see from your eyes with the other uh, image of different wavelength cameras.
system that lets you see more than just visible light. Monitor crop health throughout growing seasons by generating vegetation index maps using multispectral images. Get accurate, consistent results thanks to the integrated spectral sunlight sensor that accounts for different levels of sunlight during different times of the day. Achieve centimeter level precision with the RTK module and DJI's time sync system, allowing you to get accurate positioning data on both the RGB and multispectral images captured. DJI's iconic drone platforms have evolved for the world of work. The P4 Multispectral is an accessible tool you can rely on to collect plant-level intelligence for agricultural uses and beyond.
Okay. Okay, let's now go back to the presentation. Okay, I hope you can see the presentation now.
Yes, sir.
Okay, okay. Now, yesterday, there was a doubt that what are the disadvantages or what are the problems which are faced by the drone survey. So the main things which are creating problem are drone survey, drone, because the camera used is the visible camera. Whatever can the camera see, you can see, you can get the output. But whatever the camera cannot see, something objects which are hiding, subsurface objects, very small objects, or very thin objects like the cables, you cannot pick up in the with the camera. You cannot do the survey of those objects like below trees. So there are tree dense forest cover, and below the tree you just cannot see the land. Now the drone survey is of no use. In case of high tension lines, suppose some electricity distribution company wants you to do the survey, a normal RGB camera survey by drone is not feasible. If you have to do survey of pipes or caves, inside the pipes or caves which are over the ground, you cannot do the survey with standard RGB camera drones. Where there are no GPS, there is no GPS cover indoors. It is very difficult to do survey by drones. If you have to do, if you have to survey the underground mines, again it is very difficult, or it is not possible with a conventional drone. If you have to do this surface of the sea or the lakes, if you want to see the depth and decide what is there, or what you have to do contour model of the subsurface under the water, that is called as bathymetry, normal drone cannot do. Or some gas leak or something survey. But what I have mentioned, all this are possible with special drones. So let's see them one by one. First, below the tree in forest. So I will show you a practical example, and then you will be able to understand it very clearly. I have done two projects. Where one project where I tried, but the normal drone survey was not feasible, not possible, just because the forest cover was extremely dense.
Hello, sir. You are not audible.
Okay. Can you see the screen, ma'am?
Hi, yes. Screen is visible.
Okay. Can you see the screen, ma'am, now?
Hi, yes, sir. The previous slide
Hello?
is going on. Yes, sir. We can see the previous slide.
Oh, so you can see the slide.
Yes.
Oh, okay.
Yes. Now it is showing some map.
Okay. Okay. Can you see the survey area now?
Yes, sir.
Okay, okay. Now see this area where this is a hillside in Lonavala where they want to construct a resort. Now this is the area where they want to carry out the survey. Now you can see this is the 3D point cloud data of the area. And now you can see the land is just not visible except one or two places. Okay, and it's extremely difficult to find out. So I will show you what is the classification of this point cloud done by the system as such on its own. So let's color the point cloud. Okay, this is how the system is feeling that there are there is ground at few places, road surface at few places. Let's see one by one. So let's see. First, the system is assuming or has realized that there is a forest cover only in this area. There are buildings. These are the buildings in the area. This is all used by the artificial intelligence of the software, and it has failed because there is absolutely no ground visible. These are the road surfaces, and this is only the ground. And these are the human made objects. So the system is unable to comprehend. Even if I take over, oh, this is the original thing. Even if I take over, I have got a facility of changing the classification of the point cloud and telling the system that this is not the tree and this is land, or this is not a land, this is tree. Still I cannot extract the ground position or ground points in this area. So the drone system, the drone imagery fails in this kind of area. You have to go for a system called as lidar. I will explain it to you. I will show you the video. So I will show you where the system has worked. I will just go to the other presentation. Okay, now this is another site. Can you see the site now, ma'am?
Yes, sir, it is visible.
Okay, this is the second site. Now you can see the forest cover or the tree cover is not so thick, and you can easily extract a lot of points or a lot of ground points through this. So let's colorize those points, and this is the output what you get. If you remove high vegetations and buildings from this and human made objects, this is the final points for land you get. Then you can triangulate, you can remove this, you can see this manually. If there are few points which are left of trees, you can ignore them or you can remove them and use only the ground points to get very accurate model or model of different slopes of the ground. Much many and thousands many points than the conventional survey you get to extract the topography of the site. Now I will just shift to now the same site details in this 3D you can import in AutoCAD in 3D and work on it. I will just show it to you. So normal softwares use .las files. AutoCAD use dot.
Hello, sir. You are not audible, sir. Hello.
Okay. Ma'am, I hope you can see the slide. So this is Autodesk. This is Autodesk recap. Now the same file has been brought into recap. Okay. Now this is colorized point cloud. I'm sure you all will be knowing the the lidar will give you the same point cloud or much denser point cloud in this kind of format. It will not give you the color of the object, but it will give or it will classify the points as per the elevation or as per number of hits. So this kind of output is given by lidar, and this kind of output is given by drone. To work on this kind of output, you can easily identify which are the structures, you can easily manipulate, you can modify if you can see the actual color. So always a colorized point cloud is preferred. So most of the new lidar systems which are used to penetrate this kind of thick forest use additional camera. They are hybrid systems with combination of lidar and RGB camera. So I will just show you the same thing has been taken into AutoCAD. I will just show it to you. Okay, I'm just sharing the AutoCAD. The file is recap file. You have to just attach. It will ask you recap file and open, and the file is available in AutoCAD in 3D. If you want to change the position, you can utilize this file and work in AutoCAD in 3D. You don't require a Civil 3D or other softwares. You can use the AutoCAD and use this 3D file with the recap.rcp extension. And these are the different point clouds points which have been extracted from the drone data. This is all geo-referenced. Every point has got a lat long. Every point has got a lat long, and it will give you a if you type a specific point, it will give you the coordinates and elevation of that point. So this was how, or this is how you can import the file into AutoCAD, a 3D file of the drone output or a lidar output. Sorry, I'm not seeing the chat corner. Are there any questions till now? Till whatever I have shared? Do we have any questions?
No, sir. No questions yet.
Okay. So now let's start. I will just show you how the lidar thing is done.
Imagine a new world, effortlessly digitized by an airborne LiDAR system. Today, meet the ZenMuse L1, a payload that combines the powers of both LiDAR and visible light. It enhances the 3D data capture capabilities of drones and enables you to recreate the world. The L1 integrates a LiveOx LiDAR module, a survey-grade camera, and a high-accuracy IMU on a 3-axis gimbal. It has a detection range of up to 450 meters, and the fusion of LiDAR and RGB data produces effective true color, high-density point clouds at the centimeter-accurate level. Infrastructure assets like bridges, power lines, and towers can be modeled precisely by the L1, so you can operate and maintain them safely and efficiently. In heavily foliaged areas, its multi-return capability can penetrate vegetation canopies and capture point cloud data of ground features, as well as bare earth. Extract the vegetation point cloud to acquire information such as tree count, canopy width, and height. The remaining ground surface data can then be used to generate highly accurate digital elevation models for topographic maps. In areas with large changes in elevation, the terrain combo feature generates flight paths with variable heights to ensure the consistency of the point cloud data. Nighttime rescue missions in complex terrains have always been difficult. The L1 lets you view point cloud models in real time. Mark points, lines, and areas of interest on the live model to measure and annotate. You can verify fieldwork quality immediately and gain critical insight for on-site decision making. The ZenMuse L1 forms an integrated solution with the Matrice 300 RTK and DJI tariff. This combo changes the game for the quick creation of true color point clouds and reality models. Upgrade your toolbox with the L1. Recreate your world in vivid 3D.
Okay, now let's see another video. Now this is pure photogrammetry, high resolution, same drone. The camera had changed to a very high
The
resolution.
world of work was once again revolutionized when DJI launched the new enterprise flagship platform, the Matrice 300 RTK. With the new ZenMuse P1, unlock more of its potential. The P1 integrates a full-frame camera with interchangeable fixed-focus lenses on a 3-axis stabilized gimbal. It is an efficient, accurate payload designed for photogrammetry. For the first time, DJI uses a full-frame sensor with more microns in each pixel to give you higher image quality. At 45 megapixels and with short shooting intervals, the camera can capture high-resolution images of large areas in short flights. In just 4 flights, 140 minutes. Collect data for 10 kilometers squared of 2D orthomosaics. What's more, the P1 syncs time across the camera, gimbal, flight controller, and RTK module to deliver centimeter-level accurate data. Its global mechanical shutter with a shutter speed of 1/2000 seconds prevents the jello effect, keeping images crisp even during high-speed flights while meeting accuracy requirements of 1:500 scale cadastral surveys. Thanks to the flexible 3-axis gimbal, Smart Oblique Capture simplifies oblique photography for you to quickly generate highly accurate 3D models. In areas with elevation changes, flight paths that follow the terrain let you fly safely while improving the accuracy of data outputs. Traditional geological surveys required teams to hang from dangerous slopes. Now, with the M300 RTK and P1, map of the object photogrammetry missions are easier than ever. Vertical slopes and mountain ranges can be modeled with a millimeter level resolution, so teams can investigate, measure, and evaluate these hazard sites. Use this combo for AEC and surveying applications to quickly acquire 2D and 3D data for all phases of the project lifecycle, including design, acceptance, inspection, and maintenance. In emergency response, immediate access to the latest intel is crucial. When used with DJI Terra, the solution enables real-time mapping, so teams can have eyes on a large area to quickly make informed decisions. The ZenMuse P1 and M300 RTK solution is unprecedentedly efficient, accurate, intelligent, and safe, setting a new benchmark as your new tool for aerial survey.
Okay, so you saw different drones with different cameras. Now see another problem which was resolved by a special drone, and it is, let's see.
Every day, workers around the world put their lives at risk to perform visual inspections in complex environments. Their work demands tools that stand for simplicity, precision, and high reliability to maintain capital-intensive assets. This is Elias 2, made for indoor inspection. It's the most intuitive, reliable, and precise drone designed for the tough jobs. Imagined by top inspection professionals, brought to life by our engineers, it's built to keep workers out of harm's way, gain efficiency, and drive costs down. Elias 2 is remarkably intuitive to fly, making anyone feel like a seasoned pilot from the first flight. Take razor-sharp close-up images in GPS-denied environments, in dark and troubled airflows, beyond line of sight. Follow long and repetitive features no mirror readers. Elias 2 remains in the right distance autonomously. Fly reliably in confined spaces, go around corners and capture every inch of the most complex asset. Lightning-fast corrections on the propeller's speed and rotation direction keep Elias 2 stable at any time. When it comes to certified visual inspections, data is what matters. So we've placed Elias 2's payload in the front cage opening, fitted with a thermal and a 4K camera side by side. 12 megapixel still and video recording gives you stunning detailed images with 0.18 millimeters per pixel resolution to spot the tiniest cracks from floor to ceiling. The Elias 2 features the most powerful and intelligent lighting system ever built on a commercial drone. 10,000 lumens of light give you an increased situational awareness in large spaces. Indirect dust-proof lighting allows you to traverse dirty places without losing sight of your objective. Detecting pitting and cracks has never been easier. An oblique lighting mode reveals the texture of surfaces by creating shadows in all asperities. Because failure is not an option, a robust wireless system carries full HD live video feedback, allowing you to perform real-time inspections and make sure you always leave the site with a complete data set. The Elias 2 optimizes the way you work, from flight planning to data analysis. Preparing reports, taking 2D measurements, or building 3D models only takes a few clicks. A modular design makes Elias 2 easy to service and minimizes the reasons to ever send your drone back to flyability. The Elias 2, a major asset for those who care for their workers' safety, processes efficiency, and costs.
Okay. Okay. There are few drones which are doing some interesting thing. Hello.
Yes, sir.
Okay, somebody is asking some questions.
No, sir. There is no question in chat box.
Okay. Hello, Mr. Abhijit is asking some questions or he's speaking. Any questions you?
Abhijit, sir. Hello. Abhijit, sir.
Uh, either he's asking questions or his phone is on unmute.
Abhijit, sir, you can unmute yourself and ask question, or else you can type in chat box. Abhijit, sir, your voice is not audible.
Abhijit sir,
Suppressor, can
Okay,
we
okay, okay,
continue?
okay. I think he has put it on mute. Okay.
Yes, sir.
Because if somebody is speaking, then the sound gets added to the commentary. Okay, doesn't matter.
Okay.
So, so I just wanted to show you wherever there is a civil engineering requirement, wherever civil engineers find difficulty, drones can find a solution where, again, I tell you, wherever they find difficulty in accessing any object, seeing the details of the object, drones will certainly help, whether it is inside pipelines, on cliffs, underground mines. Now, this drone is washing the windows, which is always a painful and a risky job for all high rises. Now, a lot of business centers are coming with glass cladding or covering with all our windows, and everything is covered with glass. And those there is no access other than from outside, where one has to hang and clean these windows. These drones can certainly help. Okay. Okay. Get back to the presentation. Okay. So LIDAR is the new thing which is which is getting cheaper and cheaper every day. The cost of the LiDAR system is anywhere from 1 crore and is every day coming down to few lakhs. Now probably few systems are available less than 10 lakhs. That is only the cost of the LiDAR pod. That is the software and other drones and other things are still very costly. So it is not that uh, viable now, but probably in next 1 or 2 years you will be getting a lot of people with the lidar pod and this kind of lidar output, very detailed, accurate to less than 5 centimeters, thick forest, electricity cables, absolutely no problem, lidar will do the job. Next comes is underwater. Whenever you have to find out the surface, there are a lot of bathymetry systems are there where the ships move from one place to other. It takes a lot of time. So there are drones which are employed for doing this job. There are special sensors, special equipment which is mounted on drone. Let's see that video. This kind of output of like a lidar output 3D point cloud you get from the bathymetrics with the processing of software. Okay. Okay. Then there are drones which are capable of carrying out ground penetration radar, which can give you metal detection, mine detection, and other aspects regarding what is below the ground. So drones are being used for that job also. Even drones are, as I covered earlier, drones are the carriers of the pod. The pod or the sensor is the most important thing. In case of any emergency, a gas leak, methane gas leak, especially from a refinery or a chemical factory, drones are being dispatched first to find out the exact location of the leak, how much is the gas percentage, whether it is possible for human being to proceed, what action needs to be taken, where are the concentration, which direction the methane is flowing, everything is possible with the use of drones. Okay, to summarize, again I will repeat, drones are nothing but the carriers of the pods or the sensors. Sensors capture the data and give you different outputs by processing in different softwares. Drones are extremely useful where they are extremely efficient as they cover very large area at very short time. Very easy to dispatch a drone where a human being cannot go, hazardous situation, very risky area, jungles, traffic, everything where a human being accessibility by human being is difficult, drones can be employed. Lot of sensors, a single sensor or hybrid sensors are being used, like RGB camera, lidar, multispectral camera, thermal camera, bathymetry sensor, ground penetration radar, and combination of these, the hybrid cameras, you are getting required results in much shorter time and much accurate way. So it is up to you. You have to project the requirement that this is where we are facing problems, this is where we are having spending a lot of time, and decision making is being affected, and you will get the result because people will find a solution in terms of drones or software so that accurate, effective, efficient civil engineering work can be conducted. Not only civil engineering, that is planning, execution, monitoring, and maintenance. All these things are possible, and drones are giving a great window for you to work efficiently and effectively. So I have finished. If you have got any questions, please let me know.
Participant, do you have any questions regarding this session? You can unmute yourself and ask, sir.
Hello, sir.
Please ask.
Sir, as an academician
Okay.
or the student, suppose the application is to find out the change detection or the cropping pattern in
Okay.
a particular area.
Okay.
So what type of drone is to be acquired by the institution?
Okay.
What is the cost economics for that?
Okay. Okay.
And where is there some training courses regarding this
Nine example.
Okay. Okay.
pilot training and application of this data analysis or
Okay,
image
okay, okay,
analysis?
okay. There are a lot of questions into that. First, if you want to find out what is the change in the crop growth, correct? Correct me if I'm wrong. Crop growth only, correct?
Crop growth or crop yield?
Crop yield. Okay. So now this is there are two aspects. Crop growth can be done only by the RGB camera. Yes or no? That you take the do the survey on suppose probably 15 days or 1 month after sowing, and then do the survey again after one more month. So you know how much was previously, you can compare what is the growth. Earlier the probably plant was suppose 10 centimeter, now it has grown to 90 centimeters. Okay, so that growth can be easily done by the normal RGB camera. But if you want to see the health of the plant, then you have to use the multispectral camera. Basically, how much of green light is reflected, that means how much of chlorophyll and all other aspects, everything is can come out in the multispectral camera. Now you can have a simple drone with normal RGB camera, much cheaper. You can make it, they are readily available, and do the survey. But multispectral cameras are quite costly. They cost anywhere from 2 lakhs and above. And compatible software to process those images, that also costs nearly 10 to 15,000 minimum per month to process these images. So the cost for normal RGB survey is much lesser much cheaper. Reason being, it is done by a normal RGB camera. Any specialized sensor you put, a thermal sensor called as radiometric sensor, costs anything above 5 to 8 lakhs. Multispectral around 2 lakhs and above. LIDAR more than minimum 10 lakhs. So different sensors, I'm just saying cost of the sensor, the cost of drone and other things are much higher. The heavier the sensor, you will have to have bigger drone to carry it. So the cost of the drone will increase. So now whatever videos I showed, those are most of these sensors are from the world leaders called as DJI. This is a Chinese company which is slowly getting banned in India. But we have already imported a lot of DJI products in India, and slowly we are starting to make our own. Our startups are starting to make a lot of our own products, or any other countries we are getting those products, and it is easily possible for you to make a drone, attach these sensors, and carry out the survey. Only thing is the cost. If you are doing a business, you are doing a lot of job, then it is much cost effective to purchase a drone. Supposed to invest around 10 to 15 lakhs for such kind of job. I hope I answered. If not, you please ask me again whatever I missed.
Sir, the software required for processing the drone images and the software used for the satellite image processing, those are the one on the same that, for example.
No. First is the drone only captures images. Those images have to be stitched together. They have to be stitched together and to be made to be used in GIS software. Like these images are combined together to make a geotiff. If you attended my last lecture, I told you geotiff image, georeference TIFF image, or DSM, digital surface model, or digital terrain model. All these data output products are given by the drone processing software, for which you have to pay extra, which is around 10 to 30,000 rupees per month. And then those outputs you will be able to use in GIS software like ArcGIS or QGIS or Global Mapper for your analysis, further analysis. So every step there are different softwares and one has to pay for it.
Hello, sir.
Please tell me.
Sir, the images captured by the drone is already georeferenced, or you have to make it?
No, georeference. When the every drone, most of the, I will not say every drone is incorrect. Most of the drones now, 95% of the drones, except those small drones which children fly in their houses, 95% drones will have GPS. Now this GPS data is fed into the camera's system, and whenever the camera clicks the photographs or takes the photograph, the georeference location of that position of the drone, lat long and elevation, is stored along in that photograph as metadata. Okay, so all this data, all images are georeference. And when you generate the single map, the whole map is georeferenced.
Then the accuracy of the location depends on the GPS.
Yes, the accuracy of the whole map without the DGPS correction or without the ground control points is depending on the GPS of the drone. Okay, but you can accurately bring it to the desired level of even 1 centimeter or 2 centimeters by adding ground control points, because you have taken the photographs of the area. Before you take the photographs, you go and mark the ground, few crosses onto the ground, 6 points. You exactly know what are these points, coordinates are, and elevations are. You see them into the map. You see them in the final output, and ask the software that, okay, what you are thinking is not the coordinate. These are the coordinates. Software will realign it and bring it to the desired accuracy of 1 centimeter or less. So without GCPs, yes, there will be an error, relative error, okay, but with the GCPs, the map will be absolutely accurate.
So for GCPs, we have to have accurate GPS.
No, for GCPs, you have to extract the points of those crosses which you have marked on the ground with the help of DGPS, differential GPS.
So that is mounted on drone or separately?
No. There are two things. There are two aspects. One aspect is, one way of doing it, you do a normal survey with this crosses marked on the ground, and then tell the drone, okay, these are the actual coordinates of these points, please realign. This is called as post processing of the map. But now what, like a lot of videos which I showed, they always say RTK. RTK means real-time kinematics. So what you do, you take one base station, go to the site, find out exact location of one of the crosses, okay? Put the base station there and tell the base station, okay, these are your coordinates, okay? Now the drone is now communicating with the GPS also and with the base station. And when the camera clicks the photographs, it will record the accurate position by 1 centimeter provided by the RTK base station. That is real time kinematics. The exact coordinates of the place and elevation take where the photograph has been taken will be recorded, and that will be accurate to 1 centimeter or 2 centimeters. So effective, when you get the output, you don't require any crosses because all the photographs are georeferenced exactly within 1 centimeter, and you get the final output within 1 centimeter accuracy.
Okay. Is there any government restriction about the accuracy of these locations?
No, there are no government restrictions. Government has already taken down so many thousands of points, and they are available with a lot of government agencies. And you can, earlier they were not giving those accurate points from where you can extract other points, but now I think they have been made public. You can get you can get exact location which are being provided by Survey of India.
Okay.
Huh.
Thank you, sir.
Okay.
What about some training courses about this drone?
Is there any question? Sorry.
There are few companies which have started giving training, but now it is currently what is happening is every individual is who has got interest is trying to find out, learn from somewhere else, and start the business or other. There is no formal training as such, but a lot of firms have come up in the foreign countries. Probably you can do those training online.
Okay. Thank you, sir.
Okay.
Okay, there are no question in the chat box.
Any other questions? I will wait for probably 30 seconds. Feel free to ask any question. There's no issue.
Participants, do you have any questions?
Chalo, ma'am. Thanks a lot. I hope people have understood a few things, and at least they will be seeing the latest technology which is going to come in next few months or few years for betterment of the architecture and civil engineering field. I hope
Yes,
I have given some insight onto the latest technology. Thanks
Yes,
a lot.
sir.
Thanks a lot for inviting me.
Yes, sir. Just a minute, sir. I would like to thank you, sir, for enlightening us with this knowledge. Today's session was full of knowledge and interesting things. Thank you once again, sir. Now, participants are requested to fill the attendance link, which is provided in the chat box. We will conclude today's session here, and we will meet tomorrow at 10 a.m. for next session. Thank you. Thank you,
Thank
sir.
you very much. Thank you very much, ma'am. Have a great day. Bye.